Hello folks, we are back with the next video where we are doing the question number 8, which says that y is of the type x into x minus 2 the whole square. You have got to show that you have got to find the intervals where it is increasing. Earlier problems and all, they mentioned the domain. So that work was a little reduced. Like we don't have to search for the domain, but here now they have not told anything about the domain. So that adds our work. We will have to get the derivative and then find out the critical points. On the basis of that, divide the intervals, get that table and classify, where is it increasing and where it is decreasing. So this is going to be our work. So let's get back doing it systematically. We are having the function y as x times x minus 2. You can do it in a number of ways. Whatever way you find it convenient, you can find the derivative. Let's do it like this. This is as good as saying x squared minus 2x whole raised to 2. So getting the derivative is first getting the derivative of the exponent, then the derivative of the base. So derivative of the exponent is raised to 2, nx raised to n minus 1. That's how we go for the derivative. So first let's take the derivative of the exponent, 2x squared, x minus 1, 2 minus 1, 1. Yeah, and then derivative of the base. So derivative of this. Derivative of x squared is 2x. Derivative of 2x is 2. I hope it's clear because x squared nx n minus 1. That way it is 2x. Now this is 2 into x. 2 is a constant, doesn't have derivative, and x derivative is 1. So that way it becomes 2x minus 2. So the overall derivative is this. When we try to organize it, it will be this 2. There's a 2 common here. That can come out. And also there's an x here, 2 common here. So overall it's 4 times x into x minus 1 into x minus 2. When we have the common things coming up, there is an x common over here, so we've taken that out. There is a 2 common here, that's been taken out. So that's how you get the thing like this. Now we have to find the critical points because we have no clue about the interval. So let's have dy by dx equal to 0. Then in that case, we are left with 4 times x into x minus 1 into x minus 2 equal to 0. Each of them have to be 0. So like that, x is 0, x minus 1 is 0, x minus 2 is 0 either. Yeah, that's how we write it. So therefore you get x as 0, x as 1 and x as 2. So that gives us an idea about the interval, that here it is 0, here it is 1, here it is 2. So you have the first interval minus infinity to 0, then 0 to 1, then 1 to 2, then 2 to infinity. So many intervals you have to work. 1, 2, 3, 4 intervals. So since we are talking about the intervals, once again we go back to our table where we have the table with 3 columns. First column is first column is intervals, then sign of f dash, and then nature. So let's have that table getting ready. We have interval here, sign of f dash x, and this is nature of f. We are with y actually, sign of dy by dx. Yeah, so let's have our first interval. It is from infinity to 0. Let's take any ideal point, 1 or something like that. Sorry, minus 1 or something like that. So let's have minus 1, dy by dx at minus 1. How will be the sign? We always look at the sign. So it's like this will be negative. So it will be like 4 into minus 1, then minus 1, minus 1. So that's minus 1, minus 1. And this will be minus 1, minus 2. So basically, this is negative, this is negative, this is negative. So negative into negative, positive, positive into negative, negative. Overall sign is negative. So because the overall sign is negative, it will be a decreasing function. So like that. Then we can go for the next interval between 0 and 1. 0 and 1, you can take any point, 0 0.1, 0 0.2 till 0 0.9. Let's take 0 0.1, I think it will be simpler. So how is the dy by dx at x equal to maybe 0 0.1? How is it going to be? 4 is anyhow positive, 0 0.1 will remain positive, then 0 0.1 minus 1, then 0 0.1 minus 2. So this is going to be positive, this is negative, minus 1 plus 0 0.1 is a negative quantity. So also 0 0.1 minus 2 is also going to be a negative quantity. So negative, negative into negative, positive. So overall positive, isn't it? This is positive. Two negatives, when they multiply together, you will get a positive answer. So this is overall going to be a positive thing. So therefore, the function is increasing in this interval. Quite interesting. Then we can have the next interval between 1 and 2. Same way, I think you could take 1.1 or anything. As I told you, from 1.1 to 1.999, 1.885, all those you can take. But that will only complicate your calculations further. So that's why we try to take simpler values. dy by dx at x equal to maybe 1.1. Then in that case, we are having 4 positive. 1.1 we can substitute. Then we can have 1.1 minus 1 and 1.1 minus 2. If that is the case, then this is a positive quantity. This is also a positive quantity, 0.1. But this will be a negative quantity. So overall, it will be a negative answer. 2 positives and 1 negative in a product form is negative. So that way, this here it is going to be decreasing. And if we are not convinced about the sign, then you practically sit and calculate and find out the answer. 2 or 3 problems, when you actually find out the answer, you'll be convinced. Then in the exam, because we are only bothered about the sign, we need not waste our time in calculations. It's enough if you figure out how the sign is. Yeah. So then we come to the next interval, 2 to infinity. 2 to infinity can have 10 or 5 or 4 or 3 or something like that. Suppose if we take 10 is my favorite value always. So let's take x as 10. So what happens to 10? We'll have 4 into 10, 10 minus 1, 10 minus 2. So this is positive, this is positive, this is positive. All positives multiplied together, you're going to get a positive answer. So it's positive here, so it is increasing. Question is, where all it will be increasing. So it will be increasing in this interval and it will be increasing over here. So you can write, given, what do they ask us? Find the values of y, values of x. Yeah, y is increasing on what all intervals? It is increasing on 0, 1 and it's also increasing on 2 infinity. That's it. Your own way of writing the interpretation. So that's about it. Critical points weren't given, so we found out the critical points and then we decided the intervals, and in each interval we just found out whether it is increasing or decreasing by judiciously using the signs, etc. So that's all. That's all about this. With the next problem in the next video. Thank you.